Number 7, the equation 2x squared minus 5x equals negative 12 is rewritten in this form: 2 times x minus p squared plus q equals 0. What is the value of q? So they're kind of, if we look at this, it looks like this is now being written in vertex form, right? So we could go through here and do the math to figure this out. If we wanted to go about this and kind of find a way to let Desmos do this work for us, the q, it appears to be, would be the y value of the vertex, and then that p number would be the x value of the vertex, right? Again, if we know what vertex form, that's what it looks like. So if I took this original equation they gave me and I made it equal to 0, 2x squared minus 5x equals negative 12. If I added 12 to both sides, made this equal 0, 2x squared minus 5x plus 12 equals 0, then notice this equation equals 0, and so does this one. So at that point, that would tell me that these two must be equivalent expressions, just in different forms. So this is a standard form quadratic. So I think I could go to Desmos and just graph that equation in its standard form: 2x squared minus 5x, I think it was plus 12, yep, plus 12. But when I'm looking at this, now I'm getting this quadratic that goes like this. So the vertex would be at this point right here, right? 1.25 and 8.875. So 8.875, that would be the y value of that vertex for q, 8.875. So it seems like it would be maybe one of these answer choices. If I could find one that equals 8.875, that would be the correct answer. So if I just checked a couple of these answer choices, let's try like 167 divided by 16. That was answer choice A. Okay, that's too big. Let's delete that. Let's try 71 divided by 8. Hey, there it is. So I think our correct answer is going to be 71 over 8, because that gives us the y value of the vertex, which is what q is representing in that problem. Okay. So using Desmos, I think I was able to figure that out. But just to double check, if I went through and just actually did the completing the square on this, I would need to divide both things by 2 first to get the x squared by itself. Factor that 2 out. So divide both by 2. This gives me x squared minus 2.5x equals negative 12. And then at this point, we would draw an incomplete square. If I split up the negative 2.5, that becomes negative 1.25x in each corner. And you're more than welcome to actually do this using fractions. Let me actually show you out here to the side how that would look if we did fractions as well. So 5/2 is the same as 2.5. So at this point, I would say, okay, I have x squared. And then when I take negative 5 over 2 and I split it in half, that just makes the bottom number twice as big. So this will be negative 5/4 x times negative 5/4 x, like that. And so that negative 1.25 that I would write on the outside of the one with decimals becomes negative 5/4, the one that isn't using fractions, okay? And those things are exactly the same. And then again, on the other side, all we have is just the number negative 12. So if we complete these squares now, I need to do negative 1.25 times negative 1.25. I'm going to go to Desmos and see what that is. So negative times a negative is going to be a positive, so I'm just going to multiply the positive versions of those. So I get 1.5625. 5625. Okay, over here, negative 5/4 times negative 5/4. I'm just multiplying fractions. Negative times a negative is still a positive. And then multiplying fractions, you just do the numerators times each other and the denominators times each other. So 5 times 5 makes 25 on the top, and 4 times 4 makes 16 on the bottom. Okay. So then down here, I would say, okay, I have negative 12, and then I need to complete this square. And then depending on which version you're doing, I'm either going to take the decimal version times 2, or I'm going to take the fraction version times 2. Okay. So either I will put 1.5625. If I double that, let's see what we get. 1.5625 times 2 makes 3.125. So that would go in here. Or if I took the fraction form, the 25 over 16, then that one would have looked like, double that, you get 50 over 16, like that. And then either way, go to Desmos and type in to see what you get when you combine those. So negative 12 plus 3.125 gives me that. If I did negative 12 plus 50 over 16, I'm going to get the same thing, but if I want to keep it in a fraction form, it becomes negative 71 over 8. That looks a little familiar, right? So either I have negative 71 over 8 in fraction form or negative 8.875 here. And then on the other side, we would have 2 times either x minus 1.25 squared, or if we were doing the fractions, it would be 2 times x minus 5/4 squared. Okay. So again, I wrote out several different options for how both sides could look here. The left side could look like either one of these on my left. The right side could look like either one of those. Either way, the last step we would do is we want this to equal 0 to get it completely in the vertex form. So we would add whatever's on the right side back to the other side. That means add the 8.875, and that's the Q, or add the 71 over 8, and that's the Q. Again, those are the same numbers. And either way, you end up with this as the correct value. Okay, last one. For this video, number 8, we have this function representing the number of bacteria in a culture, 30x squared minus 30x plus 150, where x is the temperature in Celsius. What's the approximate domain of the temperatures that will keep this culture under 350? Okay, so we want to figure out what domain, what set of temperature values can we use to keep the culture under 350 bacteria. So in other words, it seems like if it gets too cold, the number of bacteria thrive, or too warm, they thrive. But somewhere in the middle, it kind of keeps the number down. And I can tell that's the case because look at this quadratic, it opens up, right? It's going to be like this. So we're trying to keep it under 350. We're like focused, when would this happen? When would it be under 350? So we go to Desmos, we graph it. So 30x squared minus 30x and plus 150. Okay, and we'll zoom out. Okay. Now, I'm also going to put in that limit. And anytime I put in a limiting number, like, hey, I want to know when it's above this number or less than this number or equal to this number, just put y equals and then that number. So there's the 350. I'll zoom in a little bit so I can clearly see the 2 places where it's exactly 350. And then tapping on the graph, here are the x values, those temperatures that would create that, negative 2.13 degrees and 3.13 degrees. Okay. And to show your work for a problem like this, when you're taking your test, just sketch the graph like I did here, even a rough sketch, and then just give the values you're getting for these. So negative 2.13, and the x value here is positive 3.13. And then pick the right answer choice. So out of all these, it looks like D is the one that is closest to those values. So there's number 7 and number 8.